Hello, in this video I'm going to show you how to express an algebraic fraction as partial fractions where you have a repeated linear factor, which just means on the denominator of your algebraic fraction, when you factorize it and write it as your factors multiplied together, one of them is repeated, so it's going to be squared. So for example, you could have 2x plus 1 over x plus 1 all squared multiplied by 2x plus 3. That would be an example where you have a repeated linear factor. Now, to kind of access this video, it's not essential, but it will probably help to have watched my previous video on partial fractions, which I'll link in the video description. And if this video is useful, please do go over to my channel where I have loads of other maths tutorials. So let's look at this first example where we need to write this algebraic fraction here in partial fractions. Now, as a reminder, writing or expressing an algebraic fraction in partial fractions just means rewriting it as multiple fractions summed together. Now, the repeated factor part, okay, this differs from the last video because if we look at the denominator, you can see here we've got x plus 1 multiplied by x plus 1. That's what we mean when we say repeated linear factor or repeated factor. Yeah, we've got it squared. Whereas in the previous video, all of the things multiplied on the denominator were unique, weren't they? So how are we going to do this? Well, thinking back to the last video, you may think about doing it like this. You might say, well, this is exactly the same as 3x plus 5 over x plus 1 multiplied by x plus 1, right? And so it might be easy to think you're going to write it as a over x plus 1 plus b over x plus 1. But there's a problem with doing this, right? And the problem is, well, if I want to sum these two fractions together, they already have the same common denominator. And so when I sum them, I'm just going to get a plus b all over x plus 1. And the problem with this is, if we look at what we need to get to, we have a 3x plus 5 on the numerator. So there's no way I'm going to end up with an x on my numerator because it's just two numbers summed together. The other problem is as well, is that on the denominator we just have x plus 1. We don't have x plus 1 all squared, okay? So let's try something different to see if this would work. We could say, alright, what if instead I write it as a over x plus 1 all squared plus b over x plus 1 all squared, because now, when I sum these two together, I'm going to end up with, well, a plus b over x plus 1 all squared. Now the denominator's looking better, but we still have that problem in the numerator. We don't have any x's there. So how are we going to fix this? Well, what we do is we build up on the denominator. So I'm going to have a over x plus 1 plus b over x plus 1 squared. You see what I mean by building up? This is to the power of 1, and this is all to the power of 2, right? And we're building up to this power here. The reason we're going to do this is because if we think now about actually summing these two fractions together, well, we need to first put a common denominator there, and to do that I would multiply the first fraction by x plus 1 on the numerator and the denominator like this, and that would give me that same common denominator. There we go, let's write it down. And so now, the denominator when I sum these is going to be x plus 1 all squared, and now this has allowed me to put an x in my numerator, right? So that's how we're going to work through these kinds of problems. Once we've actually set it up, and we've set it up now, this is all you really need to remember, is that you just build up to your squared term. You solve it in the exact same way we did when we looked at those previous examples in the last video. So what I'm going to do next is multiply everything through by the denominator, x plus 1 all squared, and that's going to give me 3x plus 5, and remember we're using an identity, is, well, a over x plus 1 multiplied by x plus 1 all squared is going to give me a multiplied by x plus 1, and if I multiply b over x plus 1 all squared by x plus 1 all squared, it's going to leave me with plus b. Now from here, if you want, you could expand and compare coefficients on both sides, but I still like to use the substitution method, okay? So I'm going to make a substitution. I'm going to say if I let x equal negative 1, well, that's going to make this bracket here equal 0, isn't it? And so that's going to allow me to find out the value of b. So let's do that. So what I'm going to do is sub x equals negative 1 into both sides of this identity. On the left hand side, that's going to give me negative 3 plus 5, which is 2. Well, we just said this term here is going to go to 0. And so actually immediately it tells me 2 must be what b is equal to. Now from here we need to think of another substitution we can do to allow us to find a. And if we take a look at this term here with a b in it, well, there's nothing I can substitute in for x that's going to remove that term, that's going to make it be multiplied by 0 like before. But that's not a problem because, remember, we now know what b is. So I can just replace b with 2. Now you might be thinking, well, we'll still have an x in here, but it doesn't matter what you substitute in for x because this is true for all values of x. So it's up to you. I'm going to say let's make x equal 0 because 0 is quite an easy number to work with. So if I let x equal 0, well, let's sub it in. On the left hand side of the identity we get 3 times 0, which is 0 plus 5, so we have 5. On the right hand side, well, I've got 0 plus 1, which is 1 times a, so that's just going to leave me with a, and we know b is 2. So now we just need to look at this. Well, 5 is exactly the same as a plus 2. Let's subtract 2 from both sides, and we get 3 must be a. And we're done. We've now expressed this in partial fractions. I know it can be written as 3 over x plus 1 plus 2 over x plus 1 all squared. Let's now look at a slightly different example. And this is where we have 3 terms multiplied together on the denominator, where one of them is repeated. Okay. Now, thinking back to how we did it in the last video, you might be tempted to calculate the partial fractions like this. You might say, it's going to be, well, a over x plus 2 all squared plus b over x plus 3. However, this isn't actually going to give you the right answer, okay? And to prove this, I'll work through it. If you're not interested, if you are just going to believe me on that, I'll timestamp where the correct example begins. But if you want to actually see for yourself that this doesn't work, let's work through it. So from here, we would multiply both sides through by this denominator, and that's going to give us 5x plus 13. And then if we multiply this term here by this denominator, we're going to get a multiplied by x plus 3. And if I multiply the second term by the denominator on the left, we're going to end up with x plus 2 all squared. Let's now do our substitution. So I'm going to say let x equal negative 3. Subbing it into the left side, well, I'm going to get 5 times negative 3, which is negative 15, plus 13 is negative 2. And on the right hand side, well, this term is going to go to 0 because I've got negative 3 plus 3, which is 0 times a is 0. And this second term, we're going to get negative 3 plus 2, which is negative 1. Negative 1 all squared is 1 times b, it's just b. So we're going to end up with negative 2 is b, so that was pretty easy. Let's do a different substitution now. Let's say let x, let's write it down, let x equal negative 2, and let's sub it in. So if I sub it in on the left hand side, I'm going to get 5 times negative 2 is negative 10, plus 13 is 3. This first term, negative 2 plus 3 is 1, 1 times a is just a, and this second term here is just going to go to 0. And so this gives me 3 must be a. Let's now sub this back in and see if it works. So this tells me it's going to be 3 over x plus 2 all squared plus minus 2, so I could just write it as minus 2 over x plus 3. Now let's sum these two fractions or subtract these two fractions and see if it takes me back to what I started with. Let's see if it works. So to do that, I'm going to put them all over a common denominator, and to do that I'm going to multiply this fraction on the numerator and denominator by x plus 3, and I'm going to multiply this fraction on the numerator and denominator by x plus 2 all squared. So let's do that now. So it's going to turn into 3 multiplied by x plus 3 all over x plus 2 all squared, x plus 3, subtract 2 lots of x plus 2 all squared all over, and I'll copy it to save a bit of time, this denominator here. Now let's actually subtract these two and simplify a little bit. So let's expand the first numerator, that's going to be 3x plus 9, and then it's going to be subtract 2 lots of, let's expand this bracket, x squared plus 4x plus 4, and remember this is now all over our common denominator like this. There we go. Let's continue to simplify on the numerator. So I've got 3x plus 9 minus 2x squared minus 8x minus 8 again, and that's all over this common denominator. Okay, let's finally simplify this. So the numerator is going to be negative 2x squared, 3x minus 8x is negative 5x, and 9 minus 8 is plus 1, all over our denominator. And hopefully you can quite clearly see these two things, let's highlight them, this and this are not the same at all. Okay, so clearly something has gone wrong here, and the problem was right at the start when we assumed that it could be represented like this, okay, because it can't. So let's see how we actually are going to do this correctly, how we're really going to lay it out. And it's not too different. Thinking back to what we did in the last question, this one here, when we had an x plus 2 all squared, or a squared term, we said we had to build up to it, didn't we? And it's exactly the same with this example here. Because it's totally possible there could be a c over x plus 2 in this sum. Yeah, it's totally possible that this term could be here. And we've kind of ignored it and assumed it wasn't there. Now once we've set it up like this, we're going to solve it the exact same way as we have with the previous ones. We're going to multiply through by this denominator here. So we're going to get 5x plus 13. And that's the exact same as a multiplied by x plus 3 plus b multiplied by x plus 2 all squared plus c multiplied by x plus 2 x plus 3. Then we do our substitutions the same as before, so I'm going to say let's start off by having x equal to negative 3. So on the left hand side of the identity we're going to get negative 15 plus 13, that's negative 2, isn't it? This is going to turn to 0. This middle term is going to be negative 3 plus 2 is negative 1. Negative 1 squared is positive 1, so that's just going to be 1b. And this third term here is going to go to 0. And so we get negative 2 is b. So it's actually the same as when we did it incorrectly, isn't it? Okay, let's do our next substitution. I'm going to say let's let x equal negative 2. So when we sub this in on the left hand side, we're going to get negative 10 plus 13 is 3. This first term is going to be negative 2 plus 3 is 1, so it's just 1a. This term goes to 0, as does this term here. And so we get 3 must be a. Let's do the final substitution for this. And you might be thinking, well, I don't know what to substitute now because there's nothing I can substitute in to make the other two terms disappear and leave me with this c term. Because, you know, if I said let x equal negative 2, that's going to make this 0. If I let x equal negative 3, it's going to make this 0. So what do? Well, just like in the previous example, you can substitute anything in. I generally, if possible, tend to go for 0, 1, or say negative 1 because they're quite nice numbers to work with. So let's try x being equal to 0. The left hand side is just going to be 13. You see it just makes it quite easy because that 5x is going to go to 0. This first term is going to be 0 plus 3, which is just 3, so 3a. The middle term is going to be 0 plus 2, which is 2. 2 squared is 4, so 4b. And then this final term is 2 times 3, which is 6, 6c. So let's write that in. So we have 13 is going to be 3a plus 4b plus 6c. And we now know what a and b are, so we can substitute those in. So I get, well, 3 lots of a, so 3 times 3, plus 4 lots of b. B is negative 2, plus 6c. And let's simplify this. I've got 9 minus 8 plus 6c. And let's simplify it a bit more. We've got 1 plus 6c. Let's subtract 1 from both sides. We get 12 is, 6c. Dividing both sides by 6, we get 2 must be c. And we found our values of a, b, and c. And so we could express this as 3 over x plus 2 all squared plus b, which was minus 2, so we could say minus 2 over x plus 3. So I'm having to go up to check what I've written. Plus c, which was 2, so plus 2 over x plus 2. And if you were to now, put all of these fractions together, you should get back to this original fraction here. Okay, so that's the only thing to remember. You need to build up to your squared term. Let's do one final example just to kind of demonstrate this again, and I'll work through it perhaps a bit faster. So we're going to take this, and we already know the format that it's going to be in thanks to the example we just did. So it's going to be a over x plus 1 plus b over x plus 1 all squared. So we've built up our powers. And then finally plus c over 2x plus 3. Let's now multiply through by this denominator here. And when we do that, we end up with 5x plus 7 equals, it's going to be a multiplied by x plus 1, 2x plus 3, plus b multiplied by 2x plus 3, plus c multiplied by x plus 1 all squared. And now we're ready to do our substitutions. So I'm going to say let x equal negative 1. So subbing that into the left hand side, we're going to get 5 times negative 1. Negative 5 plus 7 is 2. This term here is just going to go to 0. this end term is going to go to 0, and our middle term we get 2 times -1, which is -2, plus 3 is 1, so we just get left with b. And so we get 2 is b. So that was pretty straightforward. So what are we now going to do for our next substitution? Well, I'd quite like to make this bracket here equal 0, because that's going to then remove this term and allow me to find c. Now you might immediately be able to see, for that bracket to be 0, x has got to be -3/2. But if you're unsure, you can, if you want to, just say, how do I make 2x plus 3 equal to 0? What do I need to sub in? And just solve this. So subtract 3 from both sides, divide both sides by 2. Now I can see a good substitution for x is letting x equal -3/2. But I think eventually you'll just be able to spot immediately what you need to substitute in. So let's substitute it in, and it might be nice perhaps to use a calculator if you end up with fractions you don't really like the look of. So 5 times -3/2 plus 7, that's going to give us -1/2. This term here is going to go to 0, as is this middle term. And so we end up with -3/2 plus 1, which is just -1/2. And -1/2 squared is +1/4. And so we're going to end up with -1/2 is 1/4 c. And so then let's multiply both sides through by 4. And we're going to end up with, I don't know why I'm changing colour, but -2 is c. Let's do the final substitution, and remember there's nothing specifically we can substitute in to make our other term 0, and so I'm just going to choose x to be 0, because I think it's a nice number to work with, because when we do that I'm going to end up with 7. This first term is going to be 0 plus 1, which is 1, and 2 times 0 is 0, plus 3 is 3, so we've got 1 times 3, so 3a. This middle term is going to be 2 times 0 is 0, plus 3 is 3, so 3b. And finally, 0 plus 1 is 1, 1 squared is 1, so c. So let's write it out. We've got 7 is going to be 3a plus 3b plus c. And we know what b and c are, so we can substitute those in. We know that b is 2, so we get 3 times 2, and c is -2. Let's now simplify it. So we've got 3a plus 6 minus 2. And so we get 3a plus 4 is 7. Let's subtract 4 from both sides, and we get 3 is 3a. Therefore, 1 must be a. And so now we can express this in partial fractions as 1 over x plus 1 plus 2 over x plus 1 all squared, and minus 2 over 2x plus 3. And we're done. So hopefully this video was useful. If it was, please do go over to my channel where I have loads of other maths tutorials, and I'll also link my website in the video description, so you can go over there and look through all of my maths videos in one place, and I think they're a bit easier to navigate. Thanks for watching.